Are we ready to get started?
Yes.
Yes. Cool. All right.
The Jellies.
Hi, my name is Madeline. I'm one of the Education and Outreach interns here at the Mass Center for the summer. And I wanted to tell you guys all about the jellyfish of the Puget Sound. Just as a little memo about what's happening, if you guys didn't notice, we are going to be live streaming this event. So if you guys talk, the live stream will probably hear you. We're recording this for our YouTube as well, so you'll forever be immortalized in our YouTube channel, if that's what you so choose to do. And then I'm going to be using the word jellyfish, jelly, and jellies interchangeably throughout this presentation. They all mean the same thing. Technically, we like to use jelly and jellies when we talk about jellyfish, because sometimes people get confused when they hear the word fish in an animal that does not look like a fish at all. But it all means the same things for the purpose of this presentation, and I think that's a good way. If you have any questions during this, I'd love to see you guys raise your hand, but any comments or concerns, it'd be great if you have those till the end of the presentation, just so we can keep moving forward. All right, ready to get started. So, what do you guys already know about jellies? Yes.
Some of them will hurt you.
Some of them will hurt you.
They're mostly water?
They are mostly water.
They're invertebrates.
They are invertebrates.
Do they or do they not have brains?
They do not have brains.
They like plankton.
They do like plankton.
They have a short lifespan.
They do have a short lifespan. All right. If anyone has anything else, raise your hands or for everyone to peace. All right, we're going to get moving on then. So before we get started, we're going to learn some important vocab. So this vocab, it's very scientific. It's okay if you don't understand it the first time around. If you have any questions at all going into this, totally raise your hand. I'll try to do my best to explain it. But this vocab is what we're going to use to differentiate the different types of or kinds of jellyfish that exist in our water sphere. So the first word that we're going to learn about is phylum. Phylum is a level in the biological classification system that we use to note similar features in organisms to create related groups, even if they don't look the same. So they could come through the same path of evolution, but they could decide, hey, I'm going to stay on the bottom all the time, versus someone else is going to be like, I'm going to decide that I want to swim around all the time. So they're still related, but they just don't look the same. We have a couple different examples that you may know. Mollusca is a type of phylum. Ctenophore, Cnidaria are all examples of phylum that you may see in the Puget Sound itself. And then we also have Cnidaria. Cnidaria is a phylum that includes soft-bodied stinging animals like corals, sea anemones, hydroids, sea pens, and jellies. Other notable features of this phylum include a gelatinous body and the ability to reproduce both sexually and asexually. It comes from the Greek word nide, meaning metal, like that of a stinging plant. Something important to note when we talk about Cnidarias as a group is we're not exactly sure how old they are. Because of their soft bodies, it is incredibly hard to get a fossil out of them because it requires very, very specific conditions and temperatures and an environment in order for them to be properly fossilized in a way that we can then go back and look at and say, yes, this is a Cnidaria. So that means that when we say they're about 500 million years old, it's only a range, and we're saying at least 500 million years old because that's when we first get a confirmed fossil relating Cnidarias as a group. So, I kind of just said Cnidaria. So, when we talk about jellyfish, we're talking about jellyfish in the phylum Cnidaria within the class of Cytozoa. So, we'll get to that other word here in a minute. But there are creatures that look like jellyfish that can be part of a different phylum. So, one of them will be a ctenophore, where an example that we might see around here is a comb jelly. Comb jellies look pretty close to jellyfish. They've kind of got that gelatinous body going off of them, except instead of pulsing to move around, they have cilia, which are hair-like feature on their body that they can wiggle back and forth in order to move around, creating a rainbow effect on their body. We can also also have something around here known as a cell, which is a chordata. They're more closely related to us than they are some other jellyfish. They have a protonotochord as babies, which is basically a spinal cord for them that then goes away when they become an adult. Think tadpole to frog if you want a good example of how it just goes back into their body. We also have creatures that look like jellyfish that can be a part of a different class. A class is something that's underneath the phylum. So they're still part of the same phylum, but they split off a little bit further on the tree. So we have something, Cubozoa is a different class that exists in this area, that exists for jellyfish. Box jellyfish are a really good example of that. It's important to note that box jellyfish do not live around here. These are the scary jellyfish that people think about when you're talking about getting stung, but they like to live in the tropical waters near Australia, so they're of no concern to us. We also have Hydrozoa as a class that likes to exist around here. Biolumin sailors are a good example of this. These guys will typically live along the coast as they'll float along the sea, and then sometimes we'll see them on shore when they get blown in by gusts of wind due to the sail that they have on top of their body, pushing them around on top of the waves. And then now, we're going to be talking about our Psychozoa. The word Psychozoa comes from the Greek word meaning psychos, or cup. The reason why we call them a Psychozoa is because the bell of the jellyfish forms a cup when it holds all of its internal organs. And then, like as I said just the slide above, all jellyfish of this class are referred to as true jellies. So when we talk about the jellyfish of the Puget Sound, I will differentiate what type of, if these guys are true jellyfish in the Psychozoa class, or if these guys are something different. And now we're going to go into some general Psychozoa facts. Most of these can be applied to some of the other jellyfish, but these are more specific to Psychozoa. As you said earlier, these guys, the medusa or adult stage of the jellyfish, live for a few weeks to a year. But when they're in some of their other stages, like the polyp stage, they can live for a significant period of time. Additionally, whether or not they're in the wild or in an enclosed, protected environment like an aquarium will affect how long they live, where some jellyfish can grow really big and live for a lot longer when they're in a protected, food-filled environment. Psychozoas also tend to stay pretty small. On average, a psychozoa will be from about 1 inch to about 16 inches in diameter across the bell. But there are exceptions, like the lion-sitting jellyfish that you may find around here. Those guys can grow up to 6.5 feet. So it's about this big. So you would not want to meet this guy in the wild. These jellyfish will eat anything that they catch in their tentacles. They'll eat other jellyfish, fish if they can, plankton, basically anything that they can catch and won't get away, they'll try to move it towards their mouth to consume it. On their tentacles, they have something known as metacytes, which are stinging cells that they use as little harpoons to grip on, envenomate their prey, and then paralyze it so it can't get away as they move it towards their mouth. And instead of actively going after prey, jellyfish do something known as suspension feeding. Suspension feeding is when they kind of just sit in the water column and ooch around a little bit, and then they catch whatever goes in their tentacles. Suspension feeding is different than filter feeding because filter feeding often involves some sort of filtering mechanism or body part that they can use to push things out of their body that they don't want, like sand if they're closer towards the bottom, whereas jellyfish will kind of just take everything up, and if they don't like it, they'll push it back out of their mouth. Something that jellyfish also have is radial symmetry. Radial symmetry can be thought of as if you start in the center and go out like bike spokes, everything around those spokes will be the exact same all the way around. We have bilateral symmetry. For the most part, we might have some organs that are around that aren't exactly mirrored on either side, but for them, everything around their bike spokes is mirrored one after the other, all around in a circle. Continuing on, jellyfish like to swim around in groups called smacks. So if you ever see them floating around, you'll be like, there's a snack in the water. And it's really funny, and it's just kind of a fun trivia fact for you guys to know. And then one big thing about jellyfish is they are planktonic. A planktonic being is anything that is affected by the current in their movements. So jellyfish cannot swim against the current, which means that they are planktonic beings because plankton are only affected by current streams. And they cannot swim against it, and they cannot get out of it. They're stuck following the current. So if you ever see a when we talk about the jellyfish coming up here, if you ever see a different jellyfish in here, and you're like, but Madeline said those don't exist around here, just know that they might have gotten caught in a current, and they were swept in this way, and they're probably going to get swept out again as well. Where do they live? Everywhere. If there's a body of water, there is a potential for a jellyfish to be living in there. From freshwater to salt water, there could be a jellyfish, and they also live at various depths, from the very bottom of the seafloor all the way to the very top of the water. And then now we're going to go into general jellyfish anatomy. Do you guys have any questions before I move on?
I just want to know is by the wind sailors, excuse me, are they also called Belia, or is that a different
Belia?
Yeah.
So yes, Bilowind sailors are also known as Belia.
Okay.
Those, you probably saw those in articles that came up recently because there was a big event in California where a bunch of them were pushed onto the beach. People were very confused because they kind of look like plastic when they dry, and people were very considered that it was kind of a littering event. But yeah, Belia is another name for it.
I've seen them on ocean shores down
Right.
on the
Yeah.
beach. Yeah, just massive.
Yeah, just so many of them all at once. What happens with the Bilowind sailors is they have left fins and right fins. And so when wind blows through them, some will go to the left and some will go to the right. So some of them will go further out in the ocean, and then a bunch of them will get pushed up on shore.
Thank you.
Yeah. So this is what we're going to be talking about when we talk about jellyfish anatomy. This is a basic anatomy for the cyphozoa jellies. Other jellyfish may look different, like box jellyfish. That's a box, not a bell. So they may be more advanced and have different anatomy parts that don't appear on this jellyfish, but know that this is kind of like a general way that you can apply it to a bunch of different things and say, oh yes, this might be. Starting out at the very top right here, the big dome of the jellyfish is referred to as the bell or the umbrella. Smaller jellyfish are going to look more torpedo to saucer shape because they're moving around kind of small, and then bigger jellyfish are flatter for the aerodynamics because they have more to drag when they pulse. And then we have, there are two skin layers to a jellyfish. They have the epidermis, which is their outer skin layer, and then the endodermis, which is their inner skin layer. And then inside jellyfish, they have the mesoglea, which is their inner jelly. We have something known as a mesoderm, which is actually a third skin layer, which is keeping everything in place for us. Versus the jellyfish, it's a gelatinous substance that isn't considered skin. So they're a two-skin being, well, we're a three-skin being. Or tissue, excuse me. And then jellyfish have two different limbs on in their body. They have oral tentacles and or oral arms and tentacles. Both the tentacles and the oral arms of the jellyfish have the cnidocytes, or the stinging cells, which they use to capture and remove their prey. Here's a really good example of the pneumocytes that you can see over here. So the cnidocyte is what the cell is, and then the pneumocyte is something that shoots out. They're very touch sensitive, so that means that when something brushes up against them, they'll then invert their cell and push it into whatever has touched them, envenomating their prey and then making it so they can't move anymore, and keeping them from escaping. The difference between tentacles and oral arms is tentacles are what exist around the bell of the jellyfish. Think like dangly bits on a lampshade. These tentacles are typically pretty thin and can stretch really far compared to the oral arms. Oral arms can be considered more of the drapery in the internal bit of the jellyfish, and they're more centered around the mouth because they're what brings the food from the tentacles to the mouth as a mode of transport. And then getting into the mouth is the only way in and out of the body. So it's a single whole organism. This means that food, waste, and reproduction reproductive fluids all come out the same hole. The stomach digests the food in this chamber right in the middle, and then passes the remains of whatever food it ate and nutrients through interconnected canals to different parts of the body. And then our gonads are what hold the egg or the sperm of the jellyfish. So here's the important question. Do you guys think that jellyfish can see, or do you think that they just kind of float around in the water? Just float? Yeah, all right. Pardon?
I vote float.
You vote float? All right. So jellyfish actually do have a cell that is like an eye. Rhopalia allow the jellyfish to receive stimuli such as light, odors, and chemicals in the water. Within the Rhopalia, OCLs appear as the basic cell that interpret light from the environment, allowing them to react to the basic information that they can receive. And then in order for them to react from the Rhopalia, jellyfish have a basic nerve net to help them interpret the signals that they receive from the Rhopalia. So they don't have a brain, but they do have nerves that can interpret signals and cause them to flex in order to move around. And now we go into the life cycle. Before we get into the life cycle, does anyone have any questions?
About 3 slides ago, when you were showing the barbs, there was a thread. What's the thread?
Red?
Yeah. Green.
Oh, yeah. I don't remember off the top of my head. The thread is...
That's the connection point to
Okay.
whatever it's staying.
So that's how it stays attached. Is it's kind of...
So it's.
So the barb goes in, and then the thread is what sticks basically to the skin. Think of it as like another sticky layer on top of the tentacle. Right? Any other questions? All right. So there are 2 major parts in the life cycle of a jellyfish. They exist for a time as a bottom-dwelling polyp, and then they spend their time as a free-swimming medusa as they mature into an adult. Starting with the adults into babies, a medusa is either a male or a female. When breeding, males will release sperm into the water, which the female jellyfish will then take into their body to fertilize their eggs. Females will brood the eggs inside their body until it's time to release their larvae, known as planula. At that point, the planula is pushed out of the jellyfish's body, and it tries to find a place to settle, attaching itself to a surface, typically the bottom of the ocean or a rock or somewhere where it can stick and stay stuck for a little while. This allows the planula time to develop into a polyp. If you want to think of a polyp as an anemone, have you guys ever seen a plumose anemone? Plumose anemones are kind of anemones that have a long stalk and then they have something fuzzy on the top. If you want to think of a polyp like that, that might be a good example. They are related in the same family. A cyclostoma is when the polyp is sessile or immovable on the bottom or wherever it's stuck to. The polyp is what produces the free-swimming medusa. When the polyp is ready, signaled by different environmental cues, it will begin the process of strangulation. Different environmental cues can be a change in light, a change in food abundance, different temperatures in the water, or different chemicals that appear in the water that may make it decide that, okay, it's time for me to begin my next stage of life. Strobulation is when the strobula begins to separate into different stacks. Think of it like pancakes stacked one on top of the other. They typically get about 20 different strobula, one on top of the other, per strobulation period. After this has happened, they begin to pulsate. As they pop off from the stack, due to their pulsation, they are known as ephyra, which is this right here, and they begin to drift away into the water column, leaving the polyp behind. And then, following this, the ephyra begins to develop into a mature medusa over a period of weeks to months.
So is that one polyp actually releasing multiple jellies?
Yep, it can release up to 20 at one time.
Okay.
And then they also have the ability to do it again. So multiple, many fire or strobulation cycles can happen from a single polyp.
What ultimately happens to the polyp?
The polyp will stay there until it gets eaten by something or it just doesn't get enough nutrients.
So it never becomes its own gel.
No. It'll kind of stay there and then it'll get to a certain point where it can't create anymore and then it'll just die.
How big is a baby jelly?
Baby jellies, oh, they're that big. They're really small. You can see here that these guys aren't fully developed either. They kind of got like little, this is where the radial comes in, where it kind of got, and they'll fuse together as it becomes an adult. And then, before we move on, does anyone have any more questions? All right, getting to know the locals. Does anyone know the names of some of the local jellyfish that we have around here?
Fried egg, right?
Fried egg jellyfish. All right, we'll get moving on then. So the first ones we're going to talk about are the cyphozoa jellies. So these are the jellies that are considered true jellyfish. They fall into the correct phylum and the correct class to be considered true jellyfish. The first jellyfish that we're going to see is the moon jelly. So these guys are pretty local. They'll get up to 24 inches in diameter. If you guys have ever been to the Seattle Aquarium, you guys might have seen how big those guys get. So they'll get nice and not even dinner plate, but bigger than that size. But they do average about 3 inches, so much smaller. Or 3 inches tall, so will get about that thick. And then they'll average about 8 inches in diameter across the bell. They typically live in coastal waters, bays, and harbors, which is why we definitely see them around here. And they like to eat zooplankton as one of their main diets, or as part of their main diet. They're typically a translucent gray to blue in their bell with a white flower in the middle, typically with 4 petals, but there can be more. And their petal color will depend on the food that they eat. So if you guys have ever been to the aquarium during its open hours, sometimes in our moon jellyfish tank, there'll be orange in the center, and that's because we feed our jellyfish brine shrimp, which are an orange zooplankton. So their middles will turn orange instead of the white that we typically know it for. And this is very important to note that they change based on the food that they eat, because they might look like another jellyfish that we see around here, the fried egg jellyfish. You can see that in the center they're also orange. They can also go to a milky white as well, which is why it's important to know that the flower is pretty indicative of the moon jelly versus an egg yolk. The fried egg jellyfish, also known as the egg yolk, will get about 2 feet across their bell in diameter, and they'll have tentacles that can go all the way from 20 feet. So that means that even if you don't see it, it might see you or see you and still be able to sting you even if it's 20 feet away. They like to eat gelatinous zooplankton, particularly other jellies, copepods, fish larvae, and arrowworms. Kind of again though, whatever they can get in their tentacles or whatever they can bring to their mouth. They look like a cracked egg floating in the water with long translucent tentacles trailing behind it. And then once again, they'll have that milky white center. And this is important to know based on what can sting you and what can't, but we'll get to that later. And then finally, we have our lion's mane jellyfish. This is the one that can get up to 6.5 feet, but typically around here, they're going to be about 20 inches in size. So they're going to stay pretty small unless they have an abundant food source. They have really long tentacles as well. They can stretch up to 30 feet. So once again, if you're in the water and you don't see it, if you feel a sting, you still might be getting stung by a jellyfish. They like to eat tiny crustaceans, zooplanktons, small fish, and other moon jellies, which can be seen in this picture up in the top right. The bottom jellyfish in that photo is a lion's mane jellyfish, and it has 3 moon jellies caught in its tentacles. These guys range from a red-brown to yellow, with a white body surrounding their color mass. The bell is typically scalloped around the edge, which can be seen right here, where it's kind of looking like a flower around the outside, and they have long tentacles that they fall behind. into the other jellyfish. Oh, sorry, is there one more question?
Just wanted to show the 30 feet.
Oh, sure. Cool. So Grayson, one of our other interns, is going to show us what 20 feet and then what 30 feet looks like on measuring tape.
So this is 20 feet. And so 30 feet with that.
All right, watch your head when you're in construction.
That includes your tentacles.
This is the, yeah.
Yes.
So this is 30 feet. So it can get you from all the way over here. If Madeline was
Yeah.
the jelly.
Just think about it. It could touch you from all the way over there. And then you'd be like, I'm in immense pain. And you'd be very sad. Yeah.
When you find the local jellies on the beach at low tide,
Mm-hmm.
are they dead?
So it's very hard to tell when a jellyfish is dead because they can eat alive even out of the water for a short period of time. We wouldn't recommend touching them, but it's hard to tell because they don't necessarily do the like fish twitches
Yeah.
that is typically indicative of a dead or dying fish.
People always ask us when we're on the beach if the tide comes back in, and are they allowed to really, go out and
Yeah.
go back out into the coastal water? They probably do go out in the coastal water, which shouldn't be,
Yeah.
livestock. But
Should we cover them up?
Um,
Like sea
I
moss and stuff?
I mean, I wouldn't recommend that because then someone would know that they're there, and if they accidentally step on them, they either A, slip on the very slick jellyfish, or B, get stung by something that they didn't know was there. So it's better to leave them uncovered because it allows others a chance to be like, oh, there's a jellyfish over there, and I don't know what it is necessarily, but I know I'm not supposed to touch them, and I'll go around.
Yeah, I just was wondering if the sun just like doesn't, they dry.
It definitely dries them out, and then because they are made of water, it would kind of evaporate their jelly. So, yeah, they'll die on the beach if they're left there for too long, but it's harder to tell if it's dead or alive just by being on the beach.
Thank you.
Yeah. So, the cat's eye cone jelly, or the Pacific sea gooseberry, is a different phylum. These are the ctenophores. So, this jellyfish is part of a completely different, it may look like a jellyfish, but it's not actually a jellyfish. So, this guy's really teeny tiny. They're about 1/5 or a half an inch or about 1 centimeter max, but they have really long tentacles that are about 6 inches or more that come off their body. This is a really good photo that we can see over here, where it's just a teeny tiny little ball, and then it has some nice 2 long tentacles coming off of it. They like to live near shore in swarms, so sometimes you might see these guys on the beach. They typically look like a rounded egg-shaped body in the water with 2 very long tentacles coming off. And then it does have cilia along its body to help it move around, creating a rainbow effect as it pulses. And then this is a different class. This is a hydrozoa rather than a cytozoa. So same phylum, but a different class, so just branching off slightly lower on the tree. These guys can get up to 10 inches in diameter, but they average around 5 inches, and they're about 1.5 inches thick. They like coastal and open waters, and they like to eat copepods and other hydromedusa. They're nearly transparent with some very obvious radial canals that come out from the center across their bell, and they're very thick and gelatinous. So if you've ever accidentally touched one, it'll just be like a big piece of jelly floating in the water. This is a really good way to actually indicate whether or not it's a moon jelly versus a water jelly, because the radial canals only appear on the water jellies, and the moon jellies are the ones with the flower. So if you see gelatin sitting in the water, and you see the flower, it's a moon jelly, and then with the radial canals, it's a water jelly. All right. And now, before we move on, are there any other questions?
Once upon a time, we had ctenophores in the aquarium. Do you have any currently in Puget? No.
I don't think so. We just have our moon jellies right now. Any ctenophores that may come in will come in through on accident, not on purpose on our part.
Okay.
Cool. All right. Any have our Puget Sound scale, which is a cute way to know if the jellyfish sting is dangerous or not, common symptoms that you may experience, some first aid that you can do, and some medical attention that you will receive if you get stung. In the Pacific Northwest, color is a very good indicator of how severe the sting will be. If it's kind of white or translucent, the sting is not going to be very noticeable to humans. For us, it'll be like no sting or just something we won't notice. If it's got some color to it, like an egg yolk jellyfish, it'll be a mild sting. There have been, when talking about being stung before, people have said that it can be like a baby sting. It's more uncomfortable in more sensitive areas, but it's not necessarily something that you're like, hey, now it's time to go to the hospital. And then with the blind stinging jellyfish that we can see over here, that's kind of like a dark red color. That's going to indicate a more severe sting. People have said that it's like fire crawling through their body. So, you know, very more noticeable in the body and something that might encourage you to get checked out quicker. Something I do want to emphasize, this only works here. If you're going to Australia, that clear box jellyfish is certainly going to sting you and it's going to hurt severely. So we only want to apply this here. If you're trying to apply it elsewhere, it's not going to work. Some common sting symptoms that you may experience will be difficulty breathing, chest pains, muscle cramps, numbness or tingling, skin blisters, nausea or vomiting, difficulty swallowing, abdominal pain, and sometimes even excessive sweating. If you're having these symptoms at any time, you should go to the doctor. So if you're having these, go to the doctor anyway. But in relation to a sting of a jellyfish, this is a really good indication that you are having a reaction and need to go get it checked out. Things that may affect the symptoms include your age, your height, and your weight, where you were stung, because if you were stung on your arm, that's a little bit different than getting stung under an armpit or in the crevice of your knee, because it allows the venom to enter the bloodstream more quickly in more intimate areas than it does maybe necessarily on the skin. How long it's been since the sting, so if you're sitting there and it's been 2 minutes since the sting, you're, I'm okay, but an hour later, suddenly you're sweating, and you're cramping, and you're tingling everywhere. It definitely might show that the venom has progressed further into your body. And then the type of jellyfish. As we kind of just said, blue jellies, they're not going to be as big of a deal, but with the lion's mane, that might be something that you're like, okay, I'm going to get this checked out immediately. It's beneficial to have as much of this information when you're going to the ER to create a more effective treatment for you. And now we're going to go to first aid instructions that you can do if you get stung. So not everyone carries around vinegar, but you might carry around lemonade. If they're, so you want to rinse the sting site with a large amount of vinegar, lemonade, or even carbonated soda for at least 30 seconds to stop the stinging cells from continuing to react in your body. Acid is effective for all types of stings, which will, and it will stop them from continuing to be back into your body. If you notice any visible tentacles on your body, you can carefully take them off. But you have to be protected yourself, because even if you pull on your leg, suddenly they're stuck to your hands. And so you're shaking it off, and you're making the stinging cells go even more because they're pressure sensitive, as we kind of talked about when we were talking about the anatomy. So by even kind of like touching them with your hands, you're going to set them off both in your leg and into your hand. You can protect the affected area, but you're not going to want to put any pressure on it, because if there's any of the leftover stinging cells on your skin, more pressure will just cause them to react again. And suddenly you're like, my leg, it still hurts even though I wrapped it and done the right things. And then you're going to you can also apply an antihistamine or steroid cream to potentially stop any pain or itching that you may experience. And then some things that you might get at the hospital is anti-venom for the jellyfish if they have anti-venom developed for it. You can get breathing support, which would include oxygen if you're to assist with the tightening of your chest and to help you get more oxygen. You could get an EKG, which is an electrocardiogram or heart tracing, should there be any issues with your heart. You can get IV fluids to replace anything that you've just sweated out. And medicine just treat other specific symptoms that you may be experiencing. Do not do any of the following. Don't scrape out the stingers. As we were kind of just talking about, because they're pressure sensitive, if you're putting pressure on them, even when they're detached from the jellyfish, it's just going to keep those stinging cells going in your body. Don't pee on the sting site. You can think of it as like a wound. Would you want to pee on a wound? I'm going to say no. Yeah, we do not want to pee on a wound. So it's better if you try to keep it clear from anything that may cause further infection. How many of you guys have heard of meat tenderizer before? Yeah, so meat tenderizer can be like is a powder that you will put on meat as a way to tenderize it. Don't put that on the sting site either. You're not going to, tenderizing it is not going to help. And the powder won't do anything to stop the cells from going. Don't apply alcohol, ethanol, or ammonia to the sting site. That will just continue to irritate it. Don't rub it with a towel or apply pressure bandages because that's just going to add more pressure and irritate the site. And then all of these actions could irritate the sting site, causing the remaining stingers to continue to release more venom or cause an infection in the wounds. Their goal is to remove any chance of continued stinging, not create more problems. And then, do you know why you can't touch a beach jellyfish? It can still sting you. Beach jellyfish can still sting you, even on shore. Because their pressure sensitivity, even a simple brush will cause the stinger to react even after death due to the sensitivity. So that means keeping everyone away. Dogs, children, yourself, other people. That means being pointed out on the beach and saying, hey, there's something over there that you probably don't want to touch. And then of course they're going to go over there and look at it, but you can follow them and be like, don't touch it. And here's some good examples of jellyfish that you might see on the beach. We have our line sitting right here, our moon jelly, and our egg yolk. All right. Does anyone have any questions?
For that last slide, how long, I mean, are they poisonous until they basically shrivel up?
Kind of
and
until they
disintegrate?
disintegrate.
Okay.
Yep. So the best practice is don't touch it, ever. The husk will be there, and that point it's all dried out, so everything's like dead. But why be overly or underly cautious? Yes.
When the polyp is attached and making the static dangles,
It could be considered cloning because it's dividing. Yeah, it's dividing itself up into pieces, and then there are pieces that can live by themselves, so they push off. So that could be considered cloning.
so it could be forever.
Good. All right. Is that everyone's questions? Last chance. What's up?
Why can't you put sand on it?
Yeah, we'll see.
Sand.
Yeah,
So-
there's a picture of people holding sand and there's an X over it.
Oh, the sand.
Yeah, I'm talking about sand.
So you're not going to want to, like, a solution that people might do in order to get the tentacles off and a way to protect themselves is to rub sand in it. But all that's going to do is apply more pressure to the site, and it's also going to get sand in your wound. So it's not smart to do that. All right.
Totally unrelated.
Mm-hmm.
Where do Portuguese men of war fit into this marine world?
Yeah, so we're going to go back a little bit. We're traveling through time, guys. Did I go too far? No. Good, yeah. So Portuguese man of war are actually hydrozoa. So they're going to fit in with the vitamin sailors. Hydrozoa, they're a colonial animal instead of a single organism. So it's basically like a floating neighborhood. So they're all, the Portuguese men of war are also going to be down in more tropical waters, not something that we have to worry about, but they're kind of like vitamin sailors. Yes.
The Portuguese man of war venomous,
Portuguese men of war are venomous.
or by the wind sailors venomous?
Vitamin sailors are not venomous. They do not have any stinging cells that would affect. They don't have any stinging cells, I think.
Are there any really obvious visible differences between between the two?
Portuguese man of war have a lot of tentacles that can often be seen underwater if it's clearer. But these guys are a little bit flatter, and if you want to think of a Portuguese man of war as like a balloon with a fin. So they're going to be, these guys are like on top of the water, and the Portuguese man of war are a little bit under the water. Oh, and they're also significantly bigger.
How big?
Portuguese men of war about this big, and then the violin sailors are like that big.
I pulled a picture of Portuguese.
All right. If no one else has any other questions, that is the end of the presentation.
Ah.